can deal with disk, how we spoke about the methods to back up our data by creating a mirroring and parity system, where if we have a problem with a disk, we can easily recover the disk by having the data backed up on a different disk. So we've mentioned many methods with that. So today we will continue from where we left yesterday, and not yesterday, the day before yesterday. The day before yesterday, we were talking about RAID 6. Okay. Just for you to kind of understand. Remember when we spoke about RAID data distribution, where we've mentioned how the disk can be stripped, where we have if we have a group of strips from the same level, is called a stripe. So this stripe 0 is this strip from this 3 disk here. And then we've mentioned that this system of RAID distribution, where we divide the disk into strips, right? We had different type of RAID, and one of the methods for data protection in a RAID was to use a method of an XOR, which is an exclusive logical method. What does it mean? It means it gives us a true only when one of the data is true or false. So basically, the data must be different for us to have a true somewhere. Okay, so data must be completely different. All right, so this is an example here, because here we have 0 and 0, so we end up with 0 because the data are the same. Here we have a 0 and a 1, because the data are different, we have a true. Here 0 and 1, because the data are different, we have a 1. Here 1 and 1, because they are similar, we have a 0. So that's what we call exclusive OR kit. So that is very important for you to basically know that. So that is working in terms of data protection. All right. So the disk that has those so now when we spoke about common RAID levels, so we had different levels. So we mentioned RAID 0, RAID 1, RAID 5, RAID 10, and these systems are different in terms of how the stripes are built. Okay, and on today is Thursday, and on Tuesday we spoke about the RAID 6. So when we mentioned all the RAID, there was no RAID 6. So now we have the RAID 6 DP, which is the RAID 6 double parity. So when we talk about double parity, what it means here in this case now, we don't have just an horizontal parity, we also have a diagonal parity. And how does that work is that we have all these disks, so we have 4 disks here. So the horizontal parity is a result of the horizontal, so the first stripe here. So we have stripe 0 here, we have D0, D1, D2, D3, and okay, D2 and D3. So this will give us a P0. So the P0 is created by creating the XOR between these first level here. XOR, remember, is when we have 2, we need the first one to be different from the second one to have a positive output. So we have the horizontal parity, and we have the diagonal parity. So what does it mean? So the horizontal parity will basically protect against one disk failure. So if we have one disk that fails, the horizontal parity is going to protect against that. But if we have two disks, the horizontal parity by itself cannot do that. So what do? We involve a diagonal parity. So diagonal parity means that to get the information in DP0, the first stripe there, when we're stripping it into 4, the first one, to get the result, it's going to be D0 here. So here on the first disk, we take the first one. Second, we take the second. Third, we take the third. Fourth, we take the fourth. So we have a diagonal here. So we have D0, D5, D10, and D15. That will give us that one. If we take D1, D6, D11, P3, give us the second one here. And so on. So if say D2, D3, D7, and P2, we have DP2. And then D3 and P1 give us DP3. So basically that is the diagonal parity. So the diagonal parity will provide kind of a second layer of protection, which will enable recovery for two simultaneous disks. So if we have two disks that fell, we can recover them with this method. All right. So understand that, just to understand that, the first protection is provided by the horizontal parity. And then the second protection is provided by the diagonal parity. So by us having this, it means that if you have an example, for example, of a RAID 5, a RAID 5 can only survive one disk failure, while a RAID 6, DP will survive two disk failures. So even if you have two disks that failed, the system can always survive. All right, let me check in my, okay, I'm recording. All right, so this is what we have with that. So today we're going to introduce a RAID 2.0. So what is a RAID 2? A RAID 2.0. So you need to know that. So when we have what you call this a RAID 2.0, so when we think of the type of problem that we can have when we have these RAID technologies, where we actually stripping this disk into multiple strips, which on a certain level will create a stripe. Okay, so the traditional problem that we're going to have with RAIDs, so the RAID problem we're going to have is the time. Think of it, if a disk is there's a failure in the disk. Let's say you have a structure of a RAID 5. That means that maybe there's one disk. Or if you are using a RAID 6 and at the same time there's two disks that failed. So the reconstruction of those disks can be longer. You know, it can take many hours to just reconstruct the disk, depending on how many data you had on those disks. So we have the issue of a reconstruction, to reconstruct this disk when there's a data loss, okay, or where there's a fault in the disk. This can take a very long time. So because it takes a long time, it's going to affect the rest of the system, because during the time that you are trying to reconstruct while one disk, or you are trying to reconstruct a disk, another disk may fail in that time, which will create now a data loss. Because remember, now we're trying to reconstruct another disk, trying to load all the data and fix everything, and then there's another disk just fell at the same time. So now that will be a problem. So now to solve that, that's when a design of the RAID 2 was introduced. So the RAID 2 was introduced to deal with that issue. So the RAID 2 was designed just to fix those issues by so we're basically going to take, it's going to provide smaller resources. So basically, what does it mean? It means that we're going to split the data into smaller pieces or smaller blocks. So we're going to distribute those blocks evenly across many disks. So, which means that instead of rebuilding the entire disk, we're going to rebuild only the lost small blocks of data. So which will make the reconstruction much faster and reduce the risk of losing data during the rebuild. So that will work with the RAID 2.0. So the RAID 2.0 will split the data into smaller pieces, like we call them blocks. It's going to distribute those blocks more evenly across many disks, and then we're going to rebuild the lost small blocks instead of the entire disk. Okay, and then we have the RAID 2.0 plus, which is more which is kind of an enhanced version. You know, it's more advanced. So this one will use even smaller resources granularities. Okay, so which will be like the tens of kilobytes. Instead of using megabytes or gigabyte, it's going to use maybe you have 0 point something kilobytes only. So that's how it's going to divide, how it's going to create those blocks. So one block can be maybe 0.7 kilobytes only. So that's how it's going to divide the data into the disk, so that if there's any problem, it can recover just those small blocks that have a problem. So these tiny blocks are treated like virtual blocks. Okay, so they're going to be treated like just virtual blocks. So this is basically similar to how the virtual machine works in computing. Last time we spoke about virtual machines, where we can actually take what we have locally, and then we virtualize the computer and have multiple clients that use the same system. So this RAID 2.0 plus of creating these tiny blocks is going to help us to kind of just allow, obviously, a fast rebuild of the disk, because now we are dealing with really small pieces of data that need to be rebuilt. Okay, and then it's going to help as well with a better resource allocation. Why? Because the storage can be used more efficiently. And then it's very easy to just remove a disk from a certain RAID group, because we can identify these issues from a very small amount of data and fix it faster than having to fix the whole disk. Okay, so and then we have the Huawei RAID 2.0 plus. The Huawei RAID 2.0 plus is just a new RAID technology which was introduced by Huawei. What does it do? It just took so Huawei just took this further by combining the block virtualization and pool virtualization. That's how they call it. So we have the block virtualization and the pool virtualization. So they put it together. So you have your virtual for disk. So where we have like a disk level block virtualization, where we will actually break down each disk into small virtual blocks, and then we're going to distribute them evenly across disks on the system. And then we have what we call a virtual for pool. So virtual for pool, this is a pool level virtualization, where we're going to group all disks into a large resource pool. And then we're going to introduce a smart software that will manage and allocate storage resources in the system. Okay, so when we in this system of the Huawei RAID 2.0 plus, the advantage is that all disks work together. Okay, so if there's any problem, only the affected blocks are rebuilt in parallel across disk. So it has obviously it's going to have a really high reliability, because now we can rebuild the disk without losing the data, because we are building all the disk at the same time and making sure that we are building only those small portion of the disk that have been affected. So in short, the 2.0 will be faster to rebuild with smaller data block. The 2.0 plus, which uses tiny virtual blocks, will be even more efficient because we also dealing with tiny virtual blocks. And then the third one, which is the Huawei RAID 2.0, which will just add 2 layers virtualization. You have the disk and the pool virtualization. So this will make more the storage faster, safer, and really smarter. Okay. So when we talk about block virtualization, right? As we've seen it in the Huawei RAID 2.0 plus. So when we talk about block virtualization, like in RAID 2.0, you need to understand that each physical disk is actually sliced into smaller sizes, right? Which we going, like the physical disk will be sliced into small units, which we're going to call chunks or CKs. So a chunk is just a block of storage space, which can be, let's say the whole disk is 500 gigabytes, and each chunk will only be maybe 10 kilobytes. So that's how we're going to have it. So instead of managing the whole disk in one big piece, the system will manage these small chunks or CKs. All right, so that's what it means, block virtualization. So basically, if data is not evenly stored in your SSD, remember guys, we spoke about it. What is the SSD? What does SSD stand for, guys? What is an SSD? What is the SSD? Anyone?
I think it's a solid state drive.
Yes. So your SSD is just a drive, like your hard drive. So your computer or your device may have an SSD or an HDD. HDD will be the hard disk drive. SSD just stands for solid state drive. So this just like your hard drive, right? But and it's recognized and as a non-volatile storage, right? It's a bit different from your HDD because the SSD will be faster in terms of how it's managing the data. And remember, your disk has a certain rotation rate. So the SSD will be more faster than the HDD, and it's going to be more performing. Yeah, the performance is higher than HDD. So now when the data is not evenly stored in your SSDs or in your drive, right? Now, if the data is not evenly stored there, the problem now will become your system now. Your system will be slow and your system will have a problem. So your SSD, because it's heavily loaded, this may become the system bottleneck. Okay, so now by using this storage, the RAID 2.0, which means that we divide that SSD memory into multiple chunks or CKs. Okay, so how does it work? It means we divide the disk into chunks. Example, you have a 1 terabyte disk. That could be divided into many thousands of CKs. Okay, so it's like when you think of it like a loaf of bread. It's gonna be easy for you to take a full loaf of bread and have it as sliced. So when you have it sliced, it works better. So that's exactly what it means. So you picture a loaf of bread. So the loaf of bread will determine the disk, and the chunks will be the slice. So we will distribute these chunks evenly across all the disk. So each RAID stripe, right? Each RAID stripe is formed by CKs from multiple disks. So guys, remember again, a stripe, when we talk about, what is this now? When we talk about a stripe, there's a difference between, can anybody tell us the difference between a strip and a stripe? If you've been following, what's the difference between a strip and a stripe? Guys? Guys? Anyone can tell us what's the difference between a strip and a stripe? All right, so as a strip, when we're talking about a strip, sorry guys, I'm trying to draw on this, but it's not allowing me to draw on it. Can you guys still see my screen? Yeah. Can you guys still see my screen?
Yes.
All right. So when we talk about the strip, how many strips do we have in this disk? In the first disk, how many strips do we have? Guys, that's the moment I want you to unmute your mics and be interactive. How many strips do we have in this first disk?
Oh, hello, sir. I think there are 4 if we also counted the D01.
Yes, so we have 4. 1, 2. Oh, why is it not showing there? Excuse me, guys. I'm trying to draw on the. Okay, so we have 1, 2, 3, 4. These are strips. You understand? So a strip is part of one disk. So this is a RAID group, right? So this is a RAID group. In this RAID group, we have 4 disks. Disk 1, disk 2, disk 3, disk 4. So now, this here, these are backup disks. These are protection disks. And now in these 4 disks that we have here, we've stripped them into 4. Each disk was stripped into 4. So we have each disk as 4 strips. Now, when we take in a RAID group, on one level, on the same level, this is the third level. If we have to count from level 0, level 1, level 2, level 3. So on one level, all the strips forms what we call a stripe. You understand? So a stripe is a group of strips from the same level. Is that clear, guy? Any question on that? So now when we're talking about the way we divide this into chunk, it means that each RAID stripe, so we have this stripe here. What form the stripe? The stripe will be formed by all the CKs from multiple disks. So if we divide now this into multiple disks, so all disk here was 1 terabyte, and we've divided into multiple chunks of maybe 10 kilobytes. So now we're going to have all those amount of stripes there. So that will make it easy to recover the disk. You understand? So in case a disk fell, if a disk fell, instead of rebuilding the entire disk, we only gonna rebuild the missing CK, just a small portion there. That's the only thing that's gonna be rebuilt. You understand? So and rebuild is done in parallel across all the surviving disk. So if there's a problem in this, maybe one of the stripe there, one of the chunk there, there's one here. So rebuilding everything can happen at the same time. All right. So that's what that's mean. Okay, so why does this method matter? Because it's gonna help us with a with a faster reconstruction of the disk, because the CKs are rebuilt instead of rebuilding the whole disk, right? So that is very important. All right. So when we, in simple term, block virtualization will just be breaking the disk into many smaller CKs, which is the chunks. Okay. So this is going to help us with making the recovery easy. Okay. So so you need to understand here the storage system will use 2.0 plus for to distribute the data across all the LUNs. So the LUN is the logical unit. So all these, the LUNs is what you have on your computer. For example, if you open your computer, you can see you have the disk. Maybe you have your disk, which is partitioned maybe in 3, right? You have maybe your C drive, your D drive, and your F drive. I'm sure if you look at your computer, on a Windows computer, you can check on your, by checking your computer details, you can see the disk are divided, depending on when they installed operating system first, what they did, if they divided it. So this is an example of the LUN. So this is the LUN. So an LUN of an SSD is just a partition, the logical number. So here, for example, we have 3, it's divided into 3. So this rates to virtualization. So of course, how it's going to work. So we have the SSDs, which form a storage pool. So instead of managing the disk one by one, we're going to create multiple SSDs, which are grouped into a single pool. So these are the disk here. And then these SSDs here, this disk. So here we're dealing with about 8 disks. This disk will all be divided into chunks. So we're going to divide them into chunks. So that means that each SSD is sliced into small fixed sized, okay, units. For example, if this SSD was a 1 terabyte disk, maybe we divide it into 1 megabyte, 1 megabyte, 1 megabyte. So those chunks, those CKs, are basically building blocks. Think about it. Think about them that way. Okay. So now these CKs from different disks will be grouped together to a certain RAID policy. What does it mean? A certain RAID policy, it means we're going to use this disk and use maybe a system of RAID 5 or RAID 6, depending on what we want to use. Okay. So now these CKs can be divided into and then the group of these CKs here, remember these chunks here. So if we take those chunks, we form a certain group of them from different disks in a certain policy, like the RAID 5, RAID 2. We're going to create the CKGs. So a CKGs is a group of CK. Okay, so when we have those CKGs now, we can actually take them as to split them further into smaller pieces again. So this disk was maybe 1 terabyte. So we take each disk, we divide it into chunk CKs. These are CKs. Maybe all of them, each one is maybe 10 megabytes. And then we're going to take different CKs from different disks, right? Which we're going to build based on a certain policy, which can be a RAID 5 or RAID 6. So if we build them that way, those groups are called CKG, which is CK groups. Now the CKGs now will be divided further into smaller groups again, right? It's going to be divided again into smaller groups, smaller pieces of maybe 8 or 10 kilobytes. And those smaller pieces are what we're going to use to create the LUN, which is the logical unit numbers. So these small pieces are the units that are going to be mapped to create the LUN. Okay, which will be the virtual disk for certain applications. So that's how your LUN are created. All right, so the advantage of using this system over the traditional RAID system is just that your data are evenly spread across all the SSDs. And then this will prevent certain SSDs from being overloaded while others are not, right? So it also helps with a quick reconstruction. If one SSD fell, all remaining SSDs can help rebuild the lost data. Okay. So guys, for you to see how this system can work, if you work, for example, with a Microsoft, not a Microsoft, with a computer where you have multiple disks like that, where certain data of yours were saved maybe in disk C. C, usually people have C, they have their softwares and all those things, and maybe indeed they have the data there, and then F, they have other data. Guys, have you noticed that you can actually, if you have a problem, let's say in your C, there's a problem with your computer, you can actually fix your computer by only losing the softwares in C, but you keep all your data in D and F. So this is an illustration of what we are talking about here. How one disk can be divided into multiple parts. All right. So in simple term, your RAID 2.0 will basically works like breaking your SSDs into Legos. You know, when you look at the Lego that you can build, like kids play with, so those bricks, yeah. So basically your SSDs is divided into these chunks, the smaller part. So now, and then we're going to assemble those smaller parts to create a group of chunks, which will be called a CKG. And then when we take those CKGs, we divide them again into further pieces for flexible use. So those smaller pieces will now be used to create a map. We're gonna map them to create LUNs. Okay, so that's how this is going to work. So we're going to talk about the next key technology after the RAID technology will be the storage protocol. So guys, when we talk about storage protocol, what we mean by that, the storage protocol is basically how the data are transmitted between servers. Okay, between servers and storage devices. So when you have a server and then you have certain storage devices, so the server can be the host. In this case, when you have a certain server that can be online, somewhere you're trying to connect to it, but then your storage devices can be your disk or any storage system that you have. So the way the data are being transmitted is what we call a storage protocol. Okay, so it's like, think about it like a language, rules. So it's like a language or rules that the server will actually use between the server and the storage for them to talk to each other on a network. All right, so that is a protocol. So we have different type of protocols. We have SCSI, right? So we have SCSI protocol. We have SAS protocol. We have FC, which is the fiber channel. We have Internet Small Computer System Interface, which is the ISCSI. We have NFS. I think we've mentioned this a few 2 weeks ago. We have the NFS, which is the network file system. We have many other system there. Okay, so when we talk about the SCSI, so the SCSI, this stands for Small Computer System Interface. So this is just an interface developed for mid-range computers, and this is used for connecting between the host and some peripheral devices. So basically, this is one of the oldest. This is one of the oldest system that is used in terms of storage protocols. Okay, so originally it was done for directly attached storage, which we call DAS. Now it extends to the network. So basically we can do that online. So this is one of the protocols. So it works at block level. So basically we can read, write data, you understand? So this is, for example, connecting your hard drive to the server. So basically you have a server, the internal hard drive in servers use this protocol. So that hard drive in servers, it can be an HDD or SSD in servers. So they use this protocol. Yeah. All right. So this is just one of the common protocol. So when you look at it, it's basically a set, I can say a set of standards, just will help you connect and transfer data between computers and certain devices such as storage, scanners, printers. Okay, so when you look at the reason why we call it an interface technology is just that because it provides all the standard way of the host to communicate with devices. So the host, remember, is the server, communicate with devices, which can be storages and there. Okay, so this can connect to your hard drive, to SSDs, to scanners. Okay, so the SCSI here has a really high speed in terms of how the data are being transferred, and then you can use it to connect to multiple devices in one bus. I mean, so you can have, we have it sometimes. You have one USB port, and then from that USB port you can connect multiple devices. So that's the same way that it works. The SCSI. So basically, the SCSI is like kind of a translator between computers and storage. Okay. So basically, think of the SCSI as the language used between computers or servers and storage devices. So that language is called SCSI. All right. Okay, so So the SCSI is basically is also the same language that is spoken between your computer and the even when you put a disk in a computer, if your computer still have a disk, the communication is controlled by the SCSI. So how it works is that your SCSI will have an SCSI controller, right? So the SCSI controller is basically going to function like a small CPU. Remember, we spoke about the CPU, the CPU in a computer that controls how software talk to each other, how when you're dealing with your applications on your device, the CPU will control how everything is being managed. So the same way the SCSI controller will work, it's going to function just like a small CPU. It has its own command set, right? So it's going to manage all the data operation between the host, which is the computer or the server, and the devices. And then we have the SCSI bus architecture. So the SCSI will use a special bus structure that will just allow multiple devices to share the same communication channel. So this is how you get to a point where it's just like the same USB ports that you can use. You can at the same time plug your phone, the computer understand what's happening there. You can plug an hard drive, the computer still understand. You can plug a device that you just want to charge, or you can, you have different type of devices that you are plugged into the same unit. So this is how the bus architecture work in a SCSI. So the SCSI uses a special bus structure that will allow multiple devices to use the same communication channel, right? So, and then you have some of the advantages as well of this interface is just the way the whole system will understand it. So we have the host and the disk, the way all the requests are happening. So you have a multi-device support. So you can have up to even 16 devices on one bus. All right. So, and then you have a parallel task execution. That means that at the same time you have all these 16 devices plugged, you can be using all of them at the same time. All right. That is one of the biggest advantages there. Okay, so it's very good in, so you need to understand the SCSI protocol buses will allow efficient multitasking by letting the SCSI controller just manage all the communication and resources allocation among multiple devices simultaneously. So that's exactly what's happening in this system. All right, guys. So this will be all for today. Yeah. So the next class will be on Tuesday, and one thing is there anyone who didn't get a voucher for AI? Anyone who didn't get a voucher for AI? Because I've received.
I haven't.
Is you need to check your I don't know, emails. You need to check your emails. If